This video is based on optimization problems classification. We can classify optimization problems based on constraints, design variables, problem physical structure, equations, number of objective functions, and based on design variables value. Now one by one we will try to understand optimization problems classification based on constraints, design variables, objective function, equations, and other. First, we have optimization problems classification based on constraints. As we already discussed in previous video about constraints and unconstraints for optimization problems, we can classify any optimization problem using constraints and unconstraints. It depends whether constraints exist for any optimization problem or not. If constraints exist for any optimization problem, then it is a constraint-based optimization problem, else it is unconstrained optimization problem. Next classification is done based on design variables that we already discussed in previous video. Based on design variables, optimization problems are further categorized as static optimization problems and dynamic optimization problems. Here either find out the values to a set of design variables that provide minimum specified function of these variables to certain constraints, or the objective is to find a set of design variables that minimize an objective function under set of constraints, all of which are continuous function of some other variables. Here you can see first this is the static optimization problem, and here this is the dynamic optimization problem. In the static optimization problems, we have to find out the values to a set of design variables, and in dynamic optimization problems, find a set of design variables that minimize a function under set of constraints where each design variable is function to one or more than one parameters. Next classification is done based on the problem physical structure. Here it is further classified as optimal control problems and non-optimal control problems. Optimal control problems involve multiple stages, and two different types of variables are used to define it, that is state variable and control variable. Control variables determines the system variables, and it also controls the system evolution through its multiple stages. Here you can see we have n, that is total stages. On the other hand, state variables will describe the system behavior in each stage. So we have control variable that control the system variables, and it also control system evolution through its multiple stages, and variables behavior and state variable describe the system behavior in each stage. Here you can see xi, that is ith control variable, and here yi, that is the ith state variable, fi, that is ith stage to total objective function. Here you can see total objective function, that is the ith stage to total objective function like mj, gk. Next classification is done based on equations used for objective function and constraints. Here we have different types of optimization problems like linear problems, non-linear problems, geometric problems, and quadratic programming problem. In linear problems, we have both objective function and constraints linear In nonlinear problems, we have both objective function and constraints nonlinear. In geometric problems, we have both objective function and constraints polynomials, and here we have both, and here we have the objective function quadratic and constraints linear. Next classification is done based on the number of objective function. This type of classification is based on the number of objective function to be minimized. This type of classification depends on the total number of objective function to be minimized. If we have only one objective function, then it is a single objective problem. If we have more than one objective functions, then it is multi-objective problem. Here you can see we have multiple functions f1, f2 up to fn need to be minimized simultaneously. So here we discuss different types of classification for the optimization problems based on total number of objective functions need to be minimized. Next we have based on equations. Equations are used for objective function and constraints. Then based on the problem physical structure, whether it is optimal control problem or non-optimal control problem. Based on design variables, here whether it is a static optimization problem or dynamic optimization problem. And then we have based on constraint, whether the problem is constraint based or it is unconstraint based optimization problem.